Hi, my name is Kibom, and I'm going to talk about High School Math 3 Q2 BigProject. There were 11 standards that we learned in this quarter. First, ASSE2. Use the structure of an expression to identify ways to rewrite it. Second, ACED2. Create equations in two or more variables to represent relationships between quantities. Graph equations on coordinate axes with level and scales. And ACD3. Represent constraints by equation in inequalities and by systems of equations and inequalities, and interpret solutions as viable or non-viable options in a model context. For example, represent inequalities describing nutritional and cost constraints on combinations of different foods. AREI2. Solve simple rational and radical equations in one variable and give examples showing how extraneous solutions may arise. AREI11. Explain why the x-coordinates of the points where the graphs of the equation y equal to fx and y equal to gx intercept are the solution of the equation fx equal to gx. Find the solutions approximately, for example using technology to graph the functions, make tables of values, or find successive approximations. Include cases where fx and or gx are linear, polynomial, rational, absolute value, exponential, and logarithm function. FIF4. For a function that models a relationship between two quantities, interpret key features of graphs and tables in terms of the quantities, and sketch graphs showing key features given a verbal description of the relationship. Key features include intercepts, intervals where the function is increasing, decreasing, positive or negative, relative maximums and minimums, symmetries and behaviors, and periodicity. FIF5. Relate the domain of a function to its graph and, where applicable, to the quantitative relationship it describes. For example, if the function hn gives the number of person-hours it takes to assemble n engines in a factory, then the positive integers would be an appropriate domain for the function. FIF6. Calculate and interpret the average rate of change of a function, presented symbolically as a table over a specified interval. Estimate the rate of change from a graph. FIF7b. Graph square root, cube root, and piecewise defined functions, including step functions and absolute value functions. FIF7c. Graph polynomial functions, identifying zeros when suitable factorizations are available and showing and behavior. FIF7e. Graph exponential and logarithm functions showing intercepts and behavior, and trigonometric functions showing period, midline, and amplitude. Now I'm going to talk about my big project. It is about relationship between volume and pressure. I use Boyle's law. First, introduction. Basically, this project is about pressure and volume. I needed to find the relationship between them. I used GeoGebra and Desmos to find the relation, and Boyle's law equation helps me too. This situation is related to our real life too. If you see a water drop in the depth of sea, it is small, but upper part has larger water drop, because as the water drop went up, the pressure decreases, so volume increases. If the volume goes up too much, it pops, because as the volume goes up, the pressure gets lower, so it pops. Second method. GeoGebra helped me to find the prediction line from the scatter plot. Desmos helped me to check the answer. The equation PV equal to nRT was the main key for this project. P is pressure, V is volume, N is the number of molecules, R is the gas constant, and T is temperature. Third, result. Question 1, the answer was 0.4249. I found the prediction line from GeoGebra and put the number 66 at X, so I got the answer. Question 2, pressure and volume are power function because when the pressure increases, volume decreases. Furthermore, this is not inverse because X times R are not always same, so it is power function. Question 3, the pressure of the plunger of the syringe will decrease because the volume increases. Question 4. The formula is y equal to 25.15 power of negative 0.97, and I got it from GeoGebra. Question 5. Asymptote's number is the number that cannot be the solution for the graph. The line never touches it. 4. Discussion and conclusion. I couldn't know that pressure and volume are power function. When the pressure increases, volume decreases. And lastly, I used 4 standards from chemistry. They are related to this project. I could finish this project because I learned step by step, and this is the proof of it. Thank you.